Now we'll do problem 2 of the lesson 4.4-4.5. Okay, you pick up that. In this particular problem, we're to use what is called the z-score. And the z-score, we're going to use it to compare two different aptitude tests, okay, and determine which aptitude test the student performed better. Okay, and the z formula is z is equal to value, whatever value we're talking about. In this case, would be the score that the student did, minus the mean over the standard deviation. This z-score is used a lot when our distribution is normal and not skewed to the left or the right. And it's used to standardize the score so that under the standard score, the mean would be 0 and the standard deviation would be 1. But we'll get to there soon. But we're going to use it here to compare two aptitude test results, okay, and determine which one is the student performed better relative to the other test takers. Okay. A student took 2 national aptitude tests. The national mean and standard deviation were 375, and the standard deviation was 150, respectively. For the first test and the second test, the mean was 60 and the standard deviation was 8. Okay. The student scored 525 on the first test and 700 on the second test. We use the z-score to determine on which exam the student performed better relative to the other test takers. Well, here's the formula. Okay, so let's write some things down. On the first one, first exam, the mean was 375, and the standard deviation on that was 150. And the score, student score, was equal to 525. Okay. And the second exam, the mean was 60, and the standard deviation 60, and the standard deviation was 8. And the student score on the second exam was equal to 80, or 70, excuse me, 70. So we'll go there and work the problems out and see what we have. Okay, for the first, go down here for the first. We have z is equal to, the value is 525 minus the mean, which was 375, all over Standard deviation is 150. Okay. Now, let me get more perfect calculator. Need to make mistakes this way. So I'll take 525. 525 minus 375. It gives me 150. So that gives me 150 over 150, which is equal to 1. So on the first exam, the z-score was 1. Okay. Now the z-score, that's one standard deviation. Z stands for this, the number of standard deviations above and below the mean. So on the first exam, the student got one standard deviation above and below the mean, which was 375. Now let's look at the second exam. Which is Z is equal to, in that particular exam, we have the student score was 70. 70 minus the mean, which is 60, all over standard deviation, which is 8. Okay, let me run this up a little bit higher. Which comes out to be 10 over 8, right? And that is the number of standard deviations that we have above and below the mean, because that's what Z represents. We have 1.25. So since the number of standard deviations is 1.25 above and below the mean, that means that there's more percentage of fall between 1.25 standard deviations above and below the mean. So relative to other takers, he did better, performed better on the second exam, okay? So he did better on the second exam. Okay.